Good morning, Abby. So the point of today's lesson, lesson 97, is that sometimes substitution is not easy to find. Sometimes we have to, we get a number that's not an easy number to substitute. And so we have to use some type of a complex number to use substitution to solve. So we have to manipulate more than normal. So let's do this one right here. We're going to drag it over to my drawing problem, or program, I should say. Make where we can see it. All right, so let's call this one A, and let's call this one B. All right, so in equation B, I see something that I can do to make my life easier, and that is to divide everything by 2 to reduce the whole equation. So if I divide this by 2, then I'm going to get x. If I divide this by 2, I get minus 2y. And if I divide this by 2, I get negative 3. So there is b reduced, and this is totally true. I have not changed the value. All I did was reduce it. I divided every term by the same number. And if you have an equation, you can do that. And this value is still going to be the same thing it was before, right? We just divided everything by 2. So now I have a new equation for b. I'm just going to leave it, I'm going to call this b also. Call it b squared. Or b number 2. We'll call it b number 2. Actually, I'm not. I'm just going to call it b because it's the same value as b. All right. So I can create a substitution value from looking at b. I have a positive x by itself. So if I add 2y to both sides, then the value of x is 2y minus 3. And the reason I write it like that with the 2y first is because we don't want to write two symbols. So we put the positive sign number first, or term first, if we have a negative one. If we have 2, we put positive first every time. Okay, so now I have the substitution value for x, but I had to manipulate it a little bit first. I had to divide everything by 2 and then get x by itself. Now I can put this into equation A. That's what I'm going to do. So 3, and the value of x is 2y minus 3 minus 5y equals 11. All right, I just took this and put that where that x was, right there. So 6y minus 9 minus 5y is equal to 11. I'm going to add 9 to both sides. And 6y minus 5y is y by itself. Y is equal to 20. Now I can take this substitution value, the value of y, and I can put it over here. 2 times 20 minus 3. 40 minus 3. X is equal to 37. So the value here is going to be, or the point here of intersection is 37, 20. Okay? So sometimes you just have to manipulate a little bit more and get a complex number for substitution. Sometimes that's what you've got to do. Sometimes it's not a single value. Sometimes it is going to be something that's complicated. And sometimes it could be a complex fraction that you have to substitute for. That's just the way it goes. Let's do the next problem. All right, again, you have two equations. This one's going to be A. This one's going to be B. And I do that just to keep up with them, right? I can keep up with this one, I can keep up with this one by just calling it A or B and not having to say the whole thing or describe it in any way. So right away, I see that I can use elimination, right? But it tells me to use substitution to solve. I'm going to say, forget that. Even though it says use substitution, I'm going to use elimination because if the directions say use substitution to solve, and you see that there's a better way, math is about logic. Why would you not use the simpler way to solve it? Even though the directions tell you to do it something different, it's a method. It is not to get the right answer. If the direction is the word problem and it's still asking you for how many whatevers, you find the whatevers. You don't change the directions and find whatever number you want to find. I'm talking about the method. So we're going to ignore that. We're going to cancel these, and we're going to say 5x is equal to 5, x is equal to 1. We now have a substitution value for x. So I can go back to A, and I could put x in. So see, I am substituting a little bit. Plus 3y is equal to negative 7. 2 plus 3y equals negative 7. Subtract 2 from both sides. I've got 3y is equal to negative 9. Y is equal to negative 3 because I divided both sides by 3. So my answer would be 1, negative 3. So when it comes to substitution or elimination to solve, use the method that you see. They both get you to the same place. And even though it said substitution here, that would have taken longer. And math is about logic. When you can logically see the right way to do it, use that method. All right. Now, a student could absolutely use substitution from beginning to end and not use elimination at all. But that's not the smartest way to do it, is it? The smartest way to do it is the shortest method that gets you to the answer that is correct. Next question. All right, this one says use substitution to solve. So we've got A and we've got B. And right away, I'm going to change A. I'm going to reduce it by 2. So 4 divided by 2 is 2. 2 divided by 2 is 1. And 8 divided by 2 is 4. This is my new A. Okay. This allows me to create a substitution value. I'm going to subtract 2x from both sides. That's going to give me negative y is equal to 4 minus 2x. I'm going to multiply everything by negative 1. Y is equal to, and I just flip these around, 2x minus 4, because now this one's negative and this one's positive. And we only want to write one operation if we can get away with it. So now I have a substitution value for y, and I'm going to put that into b. So 3x minus 2, 2x minus 4, equals negative 4. 3x minus 4x plus 8 is equal to negative 4. Subtract 8 from both sides. 3 minus 4, that's a negative x. That's negative 12. X is equal to a positive 12 when I multiply both sides by negative 1. So I'm going to come back here and say 2 times 12 minus 4. 24 minus 4, y is equal to 20. So my answer is 12, 20. That was not super hard, but sometimes we have to look and see. We're looking for that ability to reduce, to get rid of these coefficients, so that one of these variables can be by itself. That's one of the methods for finding a substitution value. Can I reduce the entire equation? If I can reduce the entire equation, then that's going to make finding a single value or single variable to substitute with a lot easier. Next question. All right, again, I've got A and I've got B, just to give them a name. And on here, I'm looking. I don't see anything that I can reduce, right? So I'm going to use the one with the smaller numbers and create a substitution value. So that's going to be A So here's A, 3x plus 2y is equal to 5. I think what I'm going to do is solve for x. So I'm going to subtract 2y from both sides. That gives me 3x is equal to 5 minus 2y. Again, negative sign in the middle. I'm going to divide everything by 3. X is equal to 5 over 3 minus 2y over 3. That is your substitution value. It is complicated. It is advanced. That is what we're doing. We're finding the value of x to substitute in to another equation. So now let's substitute that into b. Here's b. 5 times 5 over 3 minus 2y over 3 plus 6y is equal to 7. All right, so let's get into it. 25 over 3 minus 10y over 3. I'm going to convert this to a fraction over 3. So 3 times 6 is 18y over 3. And then I'm going to convert this to a fraction over 3. 7 times 3 is 21. So 21 over 3. That allows me to get rid of the denominator. 25 minus 10y plus 18y is equal to 21. I'm going to subtract 25 from both sides. I'm going to combine these two. I have 8y is equal to negative 4. Y is equal to negative 1 over 2. Because negative 4 divided by 8 can be reduced to 1/2. And it's a negative 1/2. Now that I have this substitution value, I can put that in here to solve for x, right? And what I'm going to do is I'm going to go back to the original equation A to do that. So 3x plus 2 times negative 1/2 is equal to 5. Just because looking at this, even though this is solved for x, this would be a fraction in here. It's going to be a lot easier to solve it as a whole number with a fraction. So 3x, and I've got 2 times negative 1. It's going to be negative 2 divided by 2, so it's going to be a negative 1 is equal to 5. So adding 1 to both sides, 3x is equal to 6, x is equal to 2. So my solution is 2 and negative 1/2. And that would be how I would solve that problem. Next problem. So again, we have some numbers here. We have 2 equations. We're going to use substitution to solve. We've got equation A and equation B. Now, if you look at A, everything has a factor of 3. So I'm going to reduce that. And I'm going to say 3x divided by 3 plus 3y divided by 3 is equal to 9 divided by 3. And now I'm going to do the same thing to B. I'm going to reduce everything here by 2. So it's going to be 2x minus 3y is equal to negative 4. So now I have these most reduced forms of all of these equations, of both these equations. Now I can look at equation A, and I can say to myself, oh, well, that's really easy to create a substitution value from. So let's do that. I'm going to subtract y from both sides. So x is equal to 3 minus y. I'm going to use this and substitute it in here in equation, the reduced version of equation B. The numbers are smaller. It's easier to do the math. So we want the smaller numbers. So always reduce an equation if you can. So now 2, and the value of x is 3 minus y. Minus 3y is equal to negative 4. That is equation B in its reduced form. So 6 minus 2y minus 3y equals negative 4. If I subtract 6 from both sides, combine these two, I get negative 5y is equal to negative 10. Divide both sides by negative 5, y is equal to a positive 2. Now I can solve for x by putting the value of y in here. 3 minus 2 equals 1. So x is equal to 1, and that's my solution. 1, 2. It's not super difficult. It just means there are extra steps before you can use the equation to solve, right? Look for a way to reduce it, right? Look, how can I get this one value by itself and create some substitution? And sometimes it means it's going to be a difficult or a complex expression that you're going to substitute. Sometimes you're going to substitute a fraction. But reducing and then creating a substitution value, it's a lot easier. It's a lot easier. So do that process of looking to see if you can reduce first. Let's look at the next one. All right, so now we are in lesson number 98. And this is it's asking us to look at the relationship of numbers. So we want to find the number that is 1/8 of the way from this number to that number. It doesn't matter what the numbers are. Here's how you're going to look at that. You're going to look at this first number on the number line. That's 3, that's 4, that's 5. You're going to look at this first number, 3.5. This is your starting point, right? And then you've got, let's do 6 here. So this would be half. So a third of that would be right about there. That'd be 5 1/6. So we are looking just at this distance between these 2 points right here. And we want to find the number that is 1/8 of the way from here to here. So the first thing we have to do is find the distance here, and then we want to divide it by 8. We want to get 1/8 of that distance and add it back to the starting point so that we can come 1/8 of the way and know what this point is right here. Okay, so we're going to find the distance from the starting point to the ending point. We're going to divide it by the fraction that we have, and then that's going to be added back to the starting point in order to get to that point that is 1/8 of the way from here to here. There's a specific way that we do that. We start with the starting point. Okay? And then we're going to add to that the distance that is 1/8 of the way from, or between, I should say, the starting point actually, the range. Remember the range we used to do in data analysis? So the range is the highest minus the lowest. So the range is going to be 5 1/6 minus 3 1/2. That's going to give us the distance between these 2 points. We take the highest number minus the lowest number, and that gives us the distance, right? We need a positive number. That's why I take the highest minus the lowest. That gives us the distance between here and here. Then we divide it by 8 by multiplying it by 1/8. And then that is what gets added back to the original number. So we are adding 1/8 of this distance back to the original number with this operation right here. That's what we're doing. So that is the formula you're going to use. The starting number, or the starting point, plus the fraction times the ending number minus the starting. That is the formula you're going to use every single time. Starting point plus the fraction of the range. This is the range. And range is just another word for distance between points. Okay? Got your head wrapped around that? Let's do this problem. So first we need to solve what's in the parentheses, right? So we're going to have to turn these back into improper fractions. Let's do that for the whole thing. So that's going to be 7 over 2 plus 1 over 8 times 31 over 6 minus 7 over 2. We already did that one. All right, so I need to get everything in here to have the same denominator. The rest of this can wait. So 31 over 6 minus, that's going to be times 3, 21 over 6. Okay, not so bad. So it's going to be, so 31 minus 21, that's going to be 10 over 6, which can reduce to 5 over 3 if I divide both of these by 2. So 5 over 3, and it's okay to reduce. That's the distance. That is the distance. 1 2/3. And if we look up here, we have 1, and these would equal the 2/3 from here to here and here to here, right? So 1 2/3. All right, so we're going to trust that. Now we're going to multiply. 7 over 2 plus 5, 24. Now we need to get a common denominator, so this needs to be 24. 2 goes into 24 12 times, so we're going to say 12 over 12 times this. 12 times 7, that's 84 over 24 plus 5 over 24. That's going to be 89 over 24. That is your answer, my dear. And you can leave it as an improper fraction. You know that algebra prefers improper fractions anyway. If you want to know what it is, then you can absolutely solve it. And I do believe it's going to be, let's see, 3 times 4 is 12, carry 1. That'll be 74. So it'd be 4. 4 times 4 is 16, carry 1. That's 90, nope, that's 96. So it's not that. It's going to be 3. All right, and 3 times 24 is 72. So 89 minus 72 is going to be equal to 17. So 3, and I already wrote the 3. Hello. 17 over 24. That is the point in which it's 1/8. So 3 and 17 over 24. But the answer that we want you to type in the system is going to be the improper fraction every single time. Okay? There you go. That's how we would solve that. We're going to use this formula. The starting point plus the fraction of the range that you want to add to it. Let's do another problem. All right, so remember, we're going to find the number that is half of the way from 1/4 to 7/12. So 1/4 is the starting point. So we start that, our fraction or our expression with that, plus half of the way, so half, ending point minus starting point, and that's going to give us our range. That's the way we're going to do it every single time, okay? So this first number here is in the front and the end, and then the fraction, and then the last number here. So we do what's in the parentheses first. That's our PEMDAS. We need to make this as a common denominator with this, so we multiply this by 3. So 1/4 plus 1/2 times 7 minus 3 is 4. over 12, that's going to be 1/3. So 1 over 4 plus 1 over 6. All I need to do is convert those. So by opposite denominators, so I've got 6 over 24 plus 4 over 24 is equal to 10 over 24. That is your answer. That's 0. 10 over 24. All right, see, that's not so hard, is it? You got the range, the fraction of the range. We add it back to the starting point. Easy peasy. Next problem. All right, we've got the range, the fraction of the range, starting point. So starting point plus the fraction of the range that we want. That'd be 2, 5 over 6 minus 1, 1 over 5. Improper fractions, 6 over 5 plus 2 over 5 times 12 plus 5 is 17 over 6 minus 6 over 5. Common denominator. 5 times 17. Ugh, they would have big numbers, wouldn't they? 5 times 17. 85 over 30 minus 36 over 30. 85 minus 36, 49. So 6 over 5 plus 2 over 5, 49 over 30. Okay. Let's multiply. 6 over 5 plus 2 times 49 is 98. 5 times 30 is 150. All right, so I'm just going to multiply this by 30. So 60 times 30, or 6 times 30, 180 over 150 plus 98 over 150. 180 plus 98 is 278 over 150. I know that that's divisible by 2 at the very least. So divided by 2, that equals 139 over 75. Pretty sure 150 divided by 2 is 75. Yeah, so this will be your final answer right there. Unless you can divide it by another number that I can't see. Let's see if 139 divided by 3. No. So that's your final answer. All right, next problem. All right, find the number that is 2/7, that's our fraction, of the way. Here's our range. Starting point, 1/2 plus 2/7, that's our fraction. Here's our range, 2 1/3 minus 1/2. Improper fractions. Common denominators. That's going to be 14 over 6 minus 3 over 6. Which 14 minus 3, that's going to be 11 over 6. So 1 over 2 plus 2 over 7 times 11 over 6. Okay. Sorry, my hand is going numb because it's early in the morning and my circulation needs to get jump started. So I have to shake my hand every now and then to get the tingles out. Okay, so now we want to combine through multiplication. 22, 42. I can reduce that to make my life easier. So if I reduce this, if I divide this by 2, that's going to be 11. If I divide this by 2, that's going to be 21. So 1/2 plus 11 over 21. I don't see any common factors with that, and I don't think and 11 is a prime number, so I can't reduce it anymore. So I'm just going to have to multiply by the opposite. So this is going to be 21 over 42. I should have just left it the same thing, shouldn't I? Sometimes I'm not so smart. So 22 over 42. Now I have to bring this up. So 22 times this is, or 21 times this is 21. And 21 times this is 42. Plus 22 over 42 equals 43 over 42. That's your final answer. That's it. All right. So before you reduce, look and see if you're going to have to go back to where you were before you reduce. Save yourself a step. All right. Next and last problem for 98. All right. 1/5 of the way from 1/7 to 12 over and 2/9. All right. So starting point, fraction, range. Improper fractions. 9 times 12 is 108 plus 2. That's 110 over 9. Minus 1 over 7. Common denominator. 1 over 7 plus 1 over 5 times. So a common denominator between 9 and 7 is going to be 9 times 7, I'm pretty sure. So I need my calculator because those are big numbers. Well, this one's not. So 7 times 110 is going to be 770. And 7 times 9 is 63. Oh, I didn't even need my calculator at all. 9 times 1 is 9 over 63. I might need it now. 770 minus 9, probably not. 761. So 1 over 7 plus 1/5 of 761 over 63. All right, I want to see if 761 is divisible by 63. It's not. Okay. So now I need to do multiplication. 1 over 7 plus 761 over, what is 5 times 63? 315. Right, is 761 divisible by 315? No, it's not. All right, so now I need to get a common denominator between the two. Let me look and see if this is divisible by something to reduce it. So is 315 divisible by 7? It is. How about that? I'm going to reduce this by dividing it by 7. Actually, that means all I have to do is multiply this by 45. So that would be 45 over 315, because 7 times 45 is 315, right? So 45 times 7 is 315. So I didn't have to reduce this. Instead, all I had to do was increase this. So 45 plus 761 is 806 over 315. Now I want to see if I can reduce anything by anything. So this is divisible by 5, I know for sure. Let's see if it's divisible by 3. $105. Okay. Let's see if this is divisible by 3. 806 divisible by 3. It's not. Well, I tried. So if this is not divisible by 3, then no other number is going to work. So 806 over 315 is going to be your final answer. And that is all of lesson 97 and 98. I'm going to go ahead and do the other one later on today. Give my fingers a chance to get some circulation in them and get some breakfast. And I will go through these again like I did this one, just go through each of the problems. And I'm going to try to teach you the lesson through showing you the problems so that you understand how to solve them in that manner. Okay? All right, so girl, I want you to do well on your final. I want you to do the best job you can, and I know y'all are taking your final on Thursday, so you need this. All right, I will let you go for now. If you need any more help, specifically other than the lessons that I'm going to go ahead and send you anyway, let me know. Otherwise, I'm going to keep sending the lessons. Okay? All right. Bye for now.